Good morning all. In today's video we'll see design patterns. First, why we need design patterns, why it is called as a pattern. We know pattern means it will be repeated, so the things which are repeating for certain amount of time will be called as pattern. So the main purpose of using the patterns is to reuse. If we have designed one pattern, if we have designed one model, means we should be able to reuse it, we can able to repeat the same. So the pattern is mainly designed for the purpose of reuse. So we are going to see the GOF design pattern. First, GOF means the gang of four. The four people, Gamma, Helm, Johnson and Blitzer, have designed their design pattern. So they have designed 23 designed patterns, which are categorized as three types: creational, structural as well as behavioral. Under creational, 5 types; under structural, 12 types; under behavioral, totally there is 23 types. Okay, so in this video we are going to see about the factory design pattern. So first let us know what is creational design pattern, structural design pattern and behavioral design pattern. Creational pattern deals with creating the objects as well as class. So we'll focus only on creation of instances. Structural means it shows the physical structure. Okay, so how it will be connected. For example, assume you have object 1 as well as object 2. Object 1 have certain features, object 2 have certain features, both are different. Okay, object 1 have some other features, object 2 have some other features. But if object 1 want to use object 2, how it can be done, we'll see that in structural. And behavioral means establishing the communication between the object 1 and object 2. So these are the three types. In this video we are going to see only the factory pattern. So the problem is, who should be responsible for creating the objects when there are special considerations such as complex creation logic, a desire to separate the creation responsibilities for better cohesion and so forth, which is nothing but who is responsible for creating an object without showing any of the implementations, without showing the actual class name. Okay, so how to create it? Solution is, we had to create a pure fabrication object called as a factory that handles the creation. Okay, there is nothing but a pure application object. Okay, which follows the separation of concern principle. Separation of concern principle means we can divide the problems into multiple domains and we can code it later. We can code it whenever the client interacts with the classes, we should not expose the class name. Okay, so we'll see that. See that with an example program in Java. Here I'm going to use interface, operating system interface, which may have a specification. Okay, the method is specification. My interface name is operating system. The operating system may be of Android, Windows and iOS. These functions, these classes will also have the specification because it is an abstract method. Okay, now I am going to create an object in public static void main, and I am going to create an object for this OS class, and I want to execute the functions written over there. This is usual code, but with factory design pattern, what we'll do is we'll have the same operating system class. This is an interface. Similarly, we'll have iOS and we'll have Android and Windows. Okay, we'll have a separate interfaces and we'll have a main method, that is a client, and we are going to use a factory class. This factory class will get the data get instances. It will get the instances from this interface. Okay, instead of this design, we are going to follow this. Okay, let us see this with some example codes. I had an interface named OS, right? So public interface OS, the method inside the OS is specification. This is my OS, and I had three classes: Android, I'm going to define the method public void specification. I'm going to write system.out.println. It is a powerful OS. Similarly, I'm going to write for iOS and Windows. iOS implements operating system. Same public void specification method definition. I'm going to write it as secure. And the last class, public class Windows implements OS, public void specification. Here we can write licensed. Okay, usually we will write the without. I'm going to write the code for without factory design pattern. So my class name is test public static void main of, okay, public static void main of string args. How we can execute this? We have to create an object for OS with new Android os.spec. When this code is executed, we will get the output powerful, right? We'll get the output as powerful. If I have changed this Android to iOS, means we'll get the result as secure. If we change this Android to Windows, we'll get the result as licensed. Okay, so this is the code for this design without factory pattern. Now I want to change this to factory pattern, means this line has to be changed. Instead of that, I have one more class named factory. We have to create a class named factory public class factory. I'm going to have a method public get instance of, let us pass a string into it. Okay, if s dot equals, okay, let us say first OS, okay, whatever the input given by the user, we have to return the Android. Else if s dot equals the input string equals to second OS, means I have to return new iOS. Else I can return Windows. Return new Windows off. Okay, here the problem is that my class name Android, iOS, Windows is exposed to the client. It is not right. So we have a class factory, and I'm going to rewrite this test code. Public class test public static void main of string args. Okay, so we have to use, this is my client, I should not expose my implementation class to the client. So for that I'm going to use a factory object equal to new factory of. Okay, so here I am returning the operating system class, so the return type is OS, and I am passing and I am passing a string in the get instance of. Okay, so I have created an object for the factory class, and I am using this object to call the method get instance inside the factory class. Get instance of. Okay, if I pass first OS, means that's it. Okay, I have created an object for the factory class. Object dot get instance of. Get instance is my factory method. My string is first OS, so here s will be replaced with first OS. S dot equals first OS, so new of Android is called, which in turn returns the result as powerful. If I passed it as second OS, this case will be executed. New iOS will be called inside the factory. My result will be secure. Whatever else given here, my output will be for Windows is licensed. So this is my client code. I haven't shown any of my interface and its classes here. So this is the main advantage of using a factory pattern. I hope it will be useful for you all. Thank you so much. Good morning all. In today's